Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 7 in the CSRF module, titled CSRF where referrer validation depends on header being present. Before we continue with the exercise, I'm happy to announce that today's video is sponsored by Intigriti. Intigriti is Europe's #1 ethical hacking and bug bounty platform. Although it is European-based, you do not have to be from Europe to hack on their platform. When they first approached me to sponsor my videos, I thought that they were the perfect sponsor because the majority of you who do watch my videos watch them because you do bug bounty. I've even gotten a ton of messages telling me that my videos help people find bugs in real-world applications, which honestly makes me really happy. So if you're interested in earning some money on the side by hacking applications legally, sign up to Intigriti using the link in the description, and make sure to tweet at me or comment below when you do find bugs in their platform, because again, it makes me really happy to hear these stories. Alright, enough about our sponsor, let's go back to the exercise. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the Academy, I'm going to click on Academy, go down, select the learning path, go down, select CSRF, so cross-site request forgery, and then go down to lab number 7. And again, the title of the lab is CSRF, where referrer validation depends on header being present. Alright, let's get started. This lab's email change functionality is vulnerable to CSRF. It attempts to block cross-domain requests but has an insecure fallback. Okay, so we've got an email change functionality that's vulnerable to CSRF. So the vulnerable parameter over here is the email change functionality. It attempts to block cross-domain requests but has an insecure fallback. So they do have some kind of defense mechanism that blocks requests that don't come from the domain of the website. However, it has an insecure fallback, and what we need to do is exploit that fallback mechanism. So to solve the lab, use your exploit server to host an HTML page that uses a CSRF attack to change the viewer's email address. So the goal over here is to exploit the CSRF vulnerability to change the email address of the user. You can log into your own account using the following credentials, and we've got the credentials written right over here. All right, let's right-click on that and access the lab. While that loads up, I'm going to open up Burp Suite Professional. So for the first part of the video, just like with all the other labs, we'll do it using Burp Suite Professional. And then in the second part of the video, we'll script the exploit on our own using only features that exist in the community edition of Burp. So if you don't have Burp Suite Professional, make sure to stick around for the next part of the video. All right, click Next, Start Burp. And we'll put that right over here. Next, we're going to click on My Account and log in with the credentials that we were given. Alright, so this is the email change functionality that is vulnerable. The next thing I'm going to do is click on Foxy Proxy and set the browser to send requests to Burp. So now if we try to change the email, it should be intercepted in Burp. So click on Update Email. And here we go. It got intercepted in the proxy. Okay, let's send this to repeater and set intercept to off and work from repeater. All right, so when we click send to send the request, we get a 302, so a redirection. Then we follow the redirection and we get a 200 response telling us that the email was successfully changed. Now, if we go back to the request that is responsible for this email change, you can see that it has only one parameter, which is email, and this is the URL that it uses in order to change the email address. Now, we said that a page could be vulnerable to CSRF if it satisfies 3 conditions. The first one being a relevant action. So an action that if it happens to be vulnerable, it could cause a detrimental effect to the client or to the victim. In this case, the vulnerable functionality is the email change functionality. So if I have the ability to change the email address of a user, then I can use that email address that I control in order to change the user's password. And since it's an email address that I control, the passcode gets sent to my email, and then I can use that email in order to fully compromise the user's account. So this is definitely a relevant action, something that would cause impact to the client if exploited, and so this is satisfied. The second condition is cookie-based session handling. So the application has to use cookie-based session handling, and we can see over here, session handling is managed using a cookie called session, and so this is definitely satisfied. The last condition is no unpredictable request parameters. So we could see over here the only parameter that we have in this request is the email parameter, which is definitely predictable because we're going to change it to an email that we own, and so we know the value of this parameter. Now, if there was a CSRF token, this no longer becomes predictable because we can't predict the value of the CSRF token upfront. And so at first glance, this looks like it's vulnerable to CSRF because over here, there's no CSRF token. So it satisfies all three conditions. So what we're going to do is we're going to generate a CSRF exploit and then try to exploit this vulnerability and see if it works. Now I'm using the professional version of Burp, so I'm going to use the engagement tools and click on Generate CSRF POC. If you do not have the professional version, again, stick around to the second part of the video and we'll script it on our own without having to use the professional version. All right, first thing to do, just like with other labs, click on Options, include Auto Submit Script, and then Regenerate. Now, if we look at our exploit, you've got a form element that submits to this URL over here. So it's the change email functionality. It's a post method, just like it is with the request over here. It has one parameter, the email address, and we want to change it to an email address that we own. So let's say in this case, test1@test.ca. And then it has a submit button, and what the auto generate feature does is it automatically submits the button once the page is loaded. So let's click test in browser. So the script is hosted on Burp Suite right now. We're going to click on copy and test it in our browser. So you send this phishing link to the user, and once the user clicks it, it should change the email address of the user. So in this case, it didn't, and it says invalid referrer header. And so this is the mechanism that the exercise had mentioned. So what's happening in the backend is that they're checking the referrer header in order to ensure there's no cross-domain requests. So to understand what that means, we have to first know what a referrer header is. A referrer header is an optional request header that contains the URL of the page that is making the request. So it determines where the request is originating from. So some applications make use of this referrer header to attempt to defend against CSRF attacks by making sure that the request originated from the same domain as the website. So they ensure that the request over here came from the domain of the website, which is the random number.websecurityacademy.net. Now, if it came from anything else, it gets rejected. So let's go back to Burp Suite and proxy and see how our attack worked. So here's the change email functionality. And if we look at it over here, you could see the referrer header was Burp Suite, which is a different domain than the domain of the application over here. And that's why it's not working. So if you go to repeater, you'll see the referrer header is the exact domain of the application. And so it worked. So this in general is not a good way to defend against CSRF because the referrer header can be spoofed. It's very difficult to perform that attack. However, it is possible. Now, in this case, we're not going to try to spoof the referrer header. Instead, we're going to exploit how this was implemented in the backend. So the check for the referrer header that is implemented in the backend. And the way to do that, I usually have a list of steps for testing the referrer header. So let's write that down. The first thing I do is remove the referrer header and see if the request works. So sometimes applications, what they do is they check if the referrer header exists, then it'll validate against the domain of the application. But if it doesn't exist, that check is not performed anymore. So what I'm going to do is I'm going to remove it and see if I get a 302 response. If I do, that means the request worked. And here we go. I get a 302 response. I follow redirection. I get a 200 OK response telling me that the email was changed. So this is definitely vulnerable to CSRF because the referrer defense mechanism that they have, so checking the referrer header, is not properly implemented. And so we need to fix our POC in order to no longer send the referrer header. So by default, what happens is the referrer header is included, and it includes where the script originated from, which is, if we say test in browser, which is Burp Suite. And that's different from the domain. So what we need to do is change this a little bit in order to ensure that the referrer header does not get sent at all with the request. And to do that, we'll use the meta HTML tag, which usually exists in the head element. So we're going to say head and close that off. And then add the meta tag. So we're saying the name is the referrer header. And in this case, it's actually spelled correctly, unlike in the RFC. And then the content is equal to never. And what that does is it instructs the user agent to not include the referrer header in all the HTTP requests that originate from this document. So now if we click on test in browser, hit copy, go back, paste it, it should submit our request. And here we go, it did. Now, I didn't change this, so just to confirm, let's do test3 at test.ca, and then test in browser, copy it, put it in here, hit send, and it should change the email address, and it did. And you could see over here that the new email address is test3 at test.ca. But notice we didn't get a congratulations, you solved the lab message, and the reason is because we used the Burp Suite server instead of the exploit server. So let's do that over here. In the body, let's remove all this and add our script. So copy, paste, store the exploit, and then deliver the exploit to the victim. And here we go. It says, congratulations, you solved the lab. All right, so we successfully exploited the vulnerability by using Burp Suite Professional. Now let's script it on our own. So let's close this over here, save this, and go to our HTML document, and go back to Burp. All right, so I'm going to keep using the professional version, but any features that I use, they're going to be available in the community edition. All right, so to script the exploit, the first thing we do is add the HTML element because this is an HTML document. The next thing we do is add the head element and the meta tag that we just talked about. So to ensure that the referrer header is not included in any of the requests. And content is equal to never. Next thing we're going to do is create the body element. That's going to contain the content of the page. Let's add a heading saying hello world. And then the form element. So the form that we want to submit, we get the URL from this page over here. So I'm going to copy this. And add HTTPS. And we need the path to the change email functionality. So let's go back. Next, we need to add the method, so the request method, and we get that from over here. It's a post method. So we add post over here. And then we're going to give it an ID because we're going to reference this element. And we'll say it's called CSRF form. All right, the next thing to do is add the input element. And we'll say type is equal to hidden because we don't want the user to know that we're attacking him when he clicks on the link. We're going to say name is equal to email, and we get that from this parameter over here. And then the value is going to be, let's say, test5 at test.ca. So this is the attacker's email address, the email address that we want to change when we exploit the CSRF vulnerability. All right. This is red, which means something is wrong. Okay, and it's the input element is not closed off. All right. Next thing to do is add a script element. And say document.get element by ID. And then the element that we want to get and submit. Okay, so we want to automatically submit the request when the user clicks on the link. And so we're going to submit the form over here. The ID of the form is CSRF form. So let's copy that and put it in here. So this automatically submits the form for us. Now, the next thing I want to do is I want to include this form in an iframe. So when the user clicks on the link, I don't want him or her to see that, I'm changing the email address, the submit button is getting clicked, and then the email address gets submitted, and then the user automatically knows that the email address was changed. So I don't want the user to know that I've changed the email address of his or her account. So what I'm going to do is I'm going to submit this in an invisible iframe. So we'll do that with the iframe element. And we'll say that the style is display none so that it's invisible. And the name, let's say, is CSRF iframe. And then we close off the iframe element. Now we need to specify the target over here. So where the form will be submitted in the iframe element. So we'll say target is equal to this over here. So the CSRF iframe. Okay, let's save that. This looks good. Now, the last thing to do is to host this on our own server. So to do that, I'm going to click on terminal, new terminal, and then I'm going to host a simple Python server on localhost and port 5555. All right, so now the simple server is hosting my script. Now, the next thing to do is, let's make sure this is still running. And it timed out. So we have to create a new instance of the application. All right, let's close this as well, and spin up a new instance of the application. And we're going to need to re-log in. Hit login. All right, so this is the email address of the user. What we're going to do is attempt to change it. So the URL did change, and so we're going to have to copy this and put it in here. And this looks good. I'm going to save it. I'm going to terminate my Python server, clear this, and run it again. All right, so what we're going to do is we're going to send this malicious URL to the user. It's 127.0.0.1, and then on port 5555, and then the name of the script, so CSRF lab08.html. All right, so the user is going to click on the link, and it says error response 404 not found, and the reason is because it's lab 7 and not lab 8. So that's okay. Hit enter. And here we go. So all the user sees is a hello world page, and what should have happened in the backend is that we exploited the CSRF vulnerability and the email got changed and the user has no idea. So let's confirm that that did happen. Hit enter, and here we go. So the email was changed without the user even knowing. Alright, so we successfully exploited this vulnerability by first exploiting it using Burp Suite Professional and then scripting our own exploit. In the next lab, we'll look at other faulty implementations of checking the referrer header as a defensive mechanism to CSRF vulnerabilities. If you like the video, hit the subscribe and share button so that it reaches a wider audience. Also comment below what you learned and what you would like to see more of in the future. Thank you, and see you in the next video.